All right. I'm live, ready for round two. Um, this will be my screencast of round two of the Google Code Jam. Um, a bit of news before it starts. I am probably going to do some Twitch streaming of my contest practice for round three, assuming I get past round two. I mean, it is certainly possible I could fail on round two if I have a bad day, but um, likely I will be getting to round three, and then I'll be doing practice over the next couple of weeks. So I'm thinking, since it's not a live contest, I can actually do this format, but on Twitch. So my I am tentatively scheduling it for Friday, possibly a regular thing, Friday at 9 p.m. my time, which if you're in Eastern Europe or India or uh, or Asia is probably going to be Saturday morning. So I don't know if that time is perfect, but I'm not a morning person. So um, despite the fact that it is now 7 in the morning and I have to do this stupid contest. Anyway, we'll see how that goes. So yeah, I expect to just be doing a practice of the GCJ round one uh, questions that I haven't done yet, and possibly fielding questions if people are there. Also, I might talk about ICPC at some point. So yeah, okay, we've got four problems. Hmm. Oh, and it's an interactive problem. Their very first one is an interactive problem. Oh boy. What is the limit of the coins? Well, the coin budget. What is at most 6 times 10 to the 18? So the most obvious solution I can think of gets 1 over 2 plus 1 over 3 plus 1 over 4, etc., which will. Oh, wait. Yeah, that's fine. That should be. Yeah, for n equals 100, the sum from n equals 1 to 100 should be approximately log n, which which may be less than 6 times 10 to the 8. Uh, let's let's just see. Uh, I need to round up. Okay, so that is under 6 times 10 to the 8. So, um, I don't know. The solution seems kind of obvious to me. You just test for the minimum one, swap that out, etc., etc. I don't know. I, that seems too easy to me, but it is the first problem. All right. It's a visible verdict. Yeah. Oh, wait. It's not. Yeah, I don't think you can get. You can't. You definitely can't get by without doing it. I think the absolute minimum, or the minimum cost is 1/2 plus 1/3, et cetera, et cetera. Because to distinguish the last two elements, the highest two elements, you have to do a query of size 2. So this is going to be optimal. I mean, it's simple and it's optimal, and that makes me suspicious. But oh well. So I need to. All right. So one based positions I and j. Okay. Okay. All right. So okay. I already copied the interactive runner, so let's try it. Shouldn't need that. How does this work? I don't think I actually compiled a.cc. Okay, received wrong query. S21. That's interesting. I must be misunderstanding what M does. Position of the minimum value in the list within one based positions I and j inclusive. What? What's going on here? How can I query between 2 and 100 and get the answer 1? I assume if I do this, that's an error, right? Yeah. What is going on? I am badly misinterpreting something. Single integer representing the position. Oh, the judge responds. Oh my goodness. Okay. Interactive problems. Even a really simple one like this. Man. Where's my folder? Okay. Yeah, even a really simple one like this still got me just because of the format of the inputs and outputs. It's weird that they put in such a simple interactive problem. I mean, there's really nothing to this problem. You just do the obvious solution. You take the minimum and then you put it at the front. I assume that this is going to work because there's no randomness here. Yeah. Okay. That's really fast. These guys are really fast. All right, so this looks like a fast problem too. We'll see. A Matryoshka. Nice. A Russian doll. So I do notice that these don't share any edges. They just share vertices. Oh, they have to be regular convex polygons. I missed that. Okay, so obviously they're not going to share any edges or else they would share everything. Okay, so all this is saying is that m divides n. Okay, so n goes up to 10 to the 6th, which still isn't that large. So the total number of sides of all polygons has to be exactly n. So everything's going to be a multiple of the sides, the number of sides in the smallest polygon. So it's the number of sides of the smallest polygon, which could be 3 or 4 or 5. So we pick the smallest polygon and then we multiply it by 1 plus 1 plus 2 plus 3 plus 5 plus 6 or whatever. So once we divide out the smallest polygon, then we've just got a sequence. The optimal sequence is 1 plus 2 plus 3 plus 4 plus 5 all the way up to k. But you may have to shrink that a bit. You'll have to remove one element of that sequence if it doesn't work out. So now, does that mean it could actually be optimal to use a larger? I mean, it doesn't really matter. I can just factorize this. I can just do all possible factors of it. So I don't need to be clever, I don't think. So that's all possible factors. Oh, no, it's not 1 plus 2 plus 3 plus 4 because they have to divide each other. My mistake. Okay, so this is a little harder than I thought. Yeah, so in this case it's 1 plus 2 plus 8. Well, I subtract out x and then so I divide by 3, subtract out the 1. Yeah, so oops. So I think there's a recursive way of doing this. So you have n. Basically, you do this, and now you have a new version of the problem. So now you have m, and this has to be composed of a similar sequence. So what we're doing now, it's not quite the same sequence because the minimum possible x for this is 3. The minimum possible x for this is 2. The minimum possible starting value for this is 2. But aside from that, so that is the one exception. Aside from that, this, like, if I minimize this, or if I maximize the sequence length for m, then I will get a sequence, like multiply that by x, and I get a sequence for n, and so on and so on. So yeah, so there is a recursive solution. I haven't explained this very well. I'm sorry. It's a time sensitive contest. So yeah. So. Let me just do this. So V1. So you can always do 1. Well, V0 is equal to 0. Okay. So okay. And n is always going to be greater than 3. I did. Why did that run forever? Oh, right. Because that actually is, that's 10 to the 12. What I actually want is all factors. Do I want all factors? Do I really want to? I think I might actually want all factors. So I have to do it the other way around. 4, 3, 1. Okay, so that's not good. Okay. So 3, 1 works for 4. That's fine. 5, 1 works for 6. Wait, no. Sorry, I have that wrong. So 10 is 3 somehow. So you subtract off 2 and then divide by 2 and you end up with 4. And what's the sequence that works for 10? So does 1 work as a base case? Am I getting that right? Oops. One doesn't work as a base case. That's the problem. Okay, I think that's right. So this is like 2 plus 4 plus 8, which is exactly the minimal solution for 14. Yeah, okay, I think this is right. Oops. Obviously, I do not want my debug output in there. Wrong answer. Okay. So this is equal to 3 times 1 plus 2. Like basically for 33, you take 3, subtract it off, and divide by and you end up with, and divide by 3 and you end up with 10. And 10 indeed has 2 because that is, say, 2 plus 8, which is what we get here. We've got 2 times 3 plus 8 times 3. Okay. So 3 plus 6 is the minimum for the minimum possible with 2, as far as I can tell. So that's fine. Three plus 9 works for this. Oh, that's the wrong order. That's the problem. Changing these loops around isn't good because there's no guarantee that Vm minus x over x will be the correct order. Oh my goodness. Okay, well, a quick solution for this is this. Right. And unfortunately, you need larger test cases before that becomes obvious. That didn't work. Oh, well, it does. It's just uses a fair bit of time, but it's just pre-computation time, so it should be fine. 12 million. Yeah, it's probably going to be fine. That's a cheap hack, but whatever. I'm on a time limit. Wait, are they both visible? They're both visible. They're really going nuts with the visible verdicts in this Google Code Jam. Anyway, at least I got that done. Wow, people are tearing through this. There aren't 5 problems, are there? Jeez, this contest is not going to last these people very long. Gennady already done. Holy crap! These people are just too damn fast. All right. They really like their pancake questions. So the obvious thing of like a dynamic programming solution going from 1 to n doesn't work because you need to know the status. Basically, you need to know the visible sequence, which of course can be, there are exponentially many possibilities for the currently visible sequence. So that's no good. Um, Now, for each pancake added, we know how long it is visible. So yeah, like say our sequence is 1, 2, 3, 4, 5, 3. We have information now that tells us that these 3 pancakes are now hidden by that one. So what this tells us is that that's greater than that, greater than that, greater than that, greater than that. And then this lies between those 2 pancakes. So this gives us partial orderings. Is this like counting the number of topological sorts or something? This is probably a known problem, which is why people have gotten it so quickly. Counting the number of topological sorts given. Sorry, this isn't quite topological sorts. So for a given pancake, we know that it is larger than all the other ones up until the one that makes it invisible, and it is smaller than that one. And it's also larger than, like, we also know that it's larger than. So, like, basically for this pancake, we know it's larger than a certain set of those and a certain set of those. We know the size of that set. Like, we know exactly which elements are in that set. It's just, and we know it's smaller than this one, and that's all we know. And it's going to be smaller than that one. So each pancake has this range. We know it's larger than all of the other pancakes, greater than or equal to all the pancakes in this range, less than or equal to this, and less than or equal to this. We know these ranges for every pancake in the sequence, and that's all we know. That is complete information, I believe. Sorry, these signs are in the wrong order. So that. So, like, for this pancake, the range is this. For this one, that's the range. For this one, the range is this. For this one, the range is this. Still not quite seeing how to turn this into something, because the thing is, these ranges overlap. They're not like separate subsets. So this is going to be incomparable in our partial ordering with other things that have non-overlapping ranges, or even if they have overlapping ranges. Yeah, I mean, this is technically comparable to this because by transitivity, but aside from that, like, it's not really comparable. Aside from transitive deductions, it's not really comparable with things that are outside this range. And that's where the flexibility lies. That's where you can get multiple solutions. So what I'm looking for is some DP solution where I find a clever order to add things in. So it's not going to be this one and then this one and then this one and then this one, because there's just too much information that is saved. Um, oh, are these ranges always? Nested subsets? Yeah, like, we have that, we have that, we have that. Those are all nested. Yeah, those are all nested. I'm not sure that helps me, but this actually does form like a tree structure. Um, Does that mean that everything in here is local? Everything within this range. Um, as long as I don't run out of numbers to place. I am fumbling here. I'm not sure I'm understanding something necessary for the solution. Can I solve this recursively with DP? Yeah. Since everything's local here, what I can do is I can DP this being my substate. So my state is everything smaller than this and smaller than this. And um, and I just remember the number of pancakes that are the number, like how many small pancakes I have. So beyond this, so this limit and this limit are upper bounds. There are no real lower bounds for what I place into the sequence. So really, I'm just saying. So, like, if I remember what this limit is, and say this what this limit is, if I remember what pancakes I placed there and there, well, if I just remember the minimum, really, um, I'd have to do those in increasing order since increasing order of minimums. I'd have to do the ranges in increasing order of minimums to take into account that some of the previous pancakes could already have been taken. Yeah, that doesn't work. I'm sure nobody understands what I'm actually talking about. I'm not sure I understand what I'm talking about. This is, I am not managing to think through this problem systematically. Um, is the largest pancake always necessarily obvious? The largest pancake is. Yeah, we know where the largest pancake is. Always. Oh, and it divides everything from in left and right. So everything is local. Oh my goodness. Okay, that's a lot simpler than I was thinking. I should have. Yeah. So after realizing that this kind of DP failed, I should have realized that going from largest to smallest pancakes. I should have tried that immediately. Yeah, that's so you place the largest. You know from examination of the sequence. It's not obvious, but it's not immediately obvious. But you know from examination of the sequence where the largest pancake is going to go. So say it goes there. What this does is it splits the sequence into two disjoint sets. These do not interact in any way because you've got this largest pancake in the middle. So you can consider them to be subproblems, and then of course you're just mixing them up. You're permuting them together. So like say you do something like that, and then you find all the ways of permuting these together into a larger sequence. But yeah, all you're doing is you're recursing here and you're recursing here, and it's a linear recursion. So I mean, it's going to be n squared if you do a linear amount of work here, but that's fine. Okay. Yeah, and so yeah, if you've got a here and b here, then what you're doing is you're multiplying by a plus b. Choose a. All the ways of um, all the ways of placing elements on the left compared to elements on the right. Okay, I feel dumb. That took me too long. I really fumbled in the middle there. I sort of assumed it was harder than it was, and I should have looked at that because that is one of the sort of obvious things you should look at. So this is the lesson you should take. Like, there are some obvious approaches to problems that you should exhaust before you start thinking harder. And taking pancakes from largest to smallest is certainly an obvious kind of thing to do. So yeah. Anyway, I wasted 20 minutes there, but that's okay. Oh, n squared is not actually good enough. Okay. Um, that's fine. That's fine. It's a bit annoying because in order to calculate these combinations and permutations, I think I think I'm going to need inverses modulo this prime, which is fine. I actually have a class that does this automatically, so I'll probably just bring out that class. It's kind of high powered, but that's okay. Um, yeah. So the only problem is I need to quickly identify the largest element. Okay, so the largest element is going to be the last one, and then the next largest element is going to be the last two. Yeah, let me explain that a bit more. So I look at my sequence of pancakes. It can't go up by more than one. so the so the largest element is going to be the very last one, and then when I consider the sequence to the left, then the next largest element is going to be the next one. When I consider the sequence on the right, the next largest element is going to be the last two because I'm actually subtracting one from all of these. I have to subtract one from all of these and consider that sequence. So I guess I should use a segment tree. Is that really the easiest way? My segment tree is too complicated. My segment tree code is too complicated. Um, I always worry whenever I bring it out. I should really write a simple one for my library. Um, yeah. I do not actually need a segment tree for this. I probably should use a segment tree just because it's good practice, but yeah. Um, okay. Just going to use some globals. Because I want to recurse. Okay. I've got my mod int there. Bunch of mod int code that just allows me to automatically do all this crap, and it automatically includes modular inverses as well. So it uses the Euler method or Euclid's extended Euclid to get the modular inverse. Yeah. Okay. So what I want to do is I want to find the first position that matches n. Sorry, I want to find the last position that matches n. So so I'm just doing a binary search to find that. What I'm actually going to be doing is finding the first element after. I think this works. I think that's fine. Actually, what I should be doing is, no. Okay. Okay, if NE is in this list, then that's fine. If NE is not in this list, I'm going to get the first element past it. Okay, so what I want is upper bound -1. Why is binary search always so annoying? All right. Segmentation fault. Okay. So my binary search is probably not working. So if you were using an IDE, then you could step through this. You could set breakpoints and stuff like that. I just never learned to do that for competitive programming. So pause is ending up as 04113. So that is indeed the largest pancake. Then we recurse down to 03. But it shouldn't be E. So okay, 1, 2, and 0. I have to handle bad sequences too. Oh crap. Yeah, so that only works in that case. Okay. One, 2, 0. Okay, I'm not entirely confident in this. I'm going to submit it, but I'm going to keep working on it. Probably should have run this first. Well, that's promising. Okay. Well, that took me way too long, I'm afraid, but that's all right. People are way done. People were done long ago. That's pretty impressive, actually. I'm surprised this contest was over so quickly. Wow. Crazy. So I'm 367. Top 1,000 is needed. I'm amazed. Like, fast problems are just not my thing. Solving hard problems is probably where I'm better, just because I've got so much experience. But in my old age, I'm just not fast enough to churn through fairly easy problems like this. I feel really bad that it took me forever to see that solution. Anyway, Retiling. Let's see if this is hard. Oh, by the way, since there is one hidden test case, is there any reason to think that I would pass this and not this? I mean, this probably does not stress the modular integer stuff, the inverses and stuff like that. But the thing is, I have a template taking care of all of that. So I've just got my mod ints. All of my arithmetic is done with my mod ints. So that should be completely safe. Um, I don't even have to worry about that. So yeah, I think this is likely to be very safe. All the logic, all the special cases are probably going to be taken care of by this. The only thing that isn't is large answers and large answers like that. Okay. I'm going to feel really bad if there's a bug in my modint code so that it doesn't, like the one way that this would be a bug. Oh, it's an unsigned integer anyway, so yeah, if there's a bug then it would screw up really badly. Yeah, I think it's fine. All right, cool. Let's move on. Fairly simple problem statement. Okay, this looks like a network flow slash bipartite matching type problem. So basically, except if you ignore flipping, um, say you have the same number of greens before and after. What you're doing is you're saying, okay, to get this green to blah, say to get this green to this position, it's cost s. To get this green to this position, it's cost s. But if I were to get this green to this position, then it would be cost 2s. Um, and I don't think there's any interaction between those costs. Like, I think you can, whatever solution you get, you are going to be able to execute it. You don't need to worry about that. Um, like, sure, the paths could intersect and stuff like that, but it doesn't matter. It's not going to end up mattering for the minimum solution because you're not going to move greens that aren't necessary. You're not going to move through a green basically because that would be suboptimal. So anyway, yeah. So what you do is you find a bipartite match between two greens, and then you take the cost of flipping the last green. So the network flow solution is you set up this bipartite graph of costs from greens to greens. and then you try zero. Oh, the costs are also bounded by um, two times f, of course, because you could always just flip those. But we're going to assume that you don't flip greens, that you don't have to. Should I just swap m's and g's until g's are larger? I don't think it's going to matter. Yeah, it doesn't matter. So yeah, I start with. No, forget bounding the edge costs. The edge costs, yeah, I'm not going to bound the edge cost. So you start with moving zero greens, and then the cost of that is just, you know, to the number of greens you start with, the number of greens you end with, and then you do one flow to find out the cost of moving one green. The minimum cost, you do a one min cost max flow to find the cost of moving one green. Um, it's not max flow. You do one min cost flow to find the cost of moving one green, and then you add up a bunch of Fs, how many Fs that takes for the remaining greens, and so on. And you do that up to the minimum number of greens that you start or end with. So you're just trying all possibilities. And the thing is, you don't have to completely recompute the flow for each number of greens. In fact, the limits are small enough. You actually could completely recompute the flow. Uh, you don't have to. You really don't have to. Uh, in fact, just so I don't have to code out network flow, I mean, I always code out network flow myself from scratch, but I don't have to in this case. So I'm just going to do a bipartite match solution because with these limits, oh, sorry, I don't have a min cost bipartite match coded up. I think I am going to have to code up the flow. So yay, I'm going to code up flow. Okay, so I'm going to have 202 vertices. Okay. I never use R and C when they give it to me. I use Y and X just so I don't get them screwed up. Okay. Okay. this is ugly. I shouldn't do that, but whatever. I could have two separate loops. Okay, so $63 is just a value that you can add to itself. It's a large cost that you can add to itself. And actually, yeah, costs are never going to get larger than that. Because you have 100 times 100 times 100 times 10 to the 6 could actually overflow. That's fine. Okay. So my start vertex is going to be 200. My end vertex is going to be 201. Okay, so that's a cost which is going to be all right. So that's setting up my graph. Now, let's see. That's flipping all of the g's one way and then flipping all the other g's back. Okay. Normally I like to do flow as a DFS, but I can't in this case because I need the min cost flow. So I might as well just do it in here. Okay. Damn it! I have to do the retracing of the steps too. I really should have a min cost max flow coded up in my library. It's annoying that I don't. Or a min cost bipartite match, which is all this is. I mean, these limits are small enough you can just run the full min cost bipartite match for every n from 0 up to from 1 up to AG BG. Yeah. Well, that's a lapse in my library. I feel bad. I should rectify this. When I code up flow myself, I always code it as a DFS, but it's not min cost max flow. It's just max flow, and I always do that as a DFS, and I just code that up because it's a fairly simple DFS. But in this case, I need min cost max flow. So annoying. I always have to use this trick for priority queue since it orders in the unintuitive way, which sucks. Top first rather than bottom first. Yeah. I think this is fine. All right, I think that does it. Huh? Oops. You'd think I'd have typed that enough that I got it right, that I would always get it right. All right, C is not declared the scope. Doesn't matter. Okay, so that's not right. Now that's a problem. Is my solution completely wrong? No, I think it's fine. I think I just need to ignore all the cases where a swap is not needed. I think that's fine. Yeah, okay. I'll give it a try. Although it's possible my network flow that I coded in haste is wrong. So Runtime error. Yeah, okay. Sorry. Um, okay. Let's see if I can just trigger the error myself. Nope. Ah, okay. Oh, my stupid solution here. Uh, oh my goodness, and this just doesn't work. Okay, screw this. Terrible. That's so embarrassing. Oops. Nope. Okay. Why did I try to be clever just to avoid a loop? That's so stupid. I'm kind of lucky that I caught that, but that's you put in the boundary cases, and fortunately, that was a boundary case that happened on. Okay, wrong answer. That's progress. Um, Wrong answer is a little bit harder for me to debug. So FS. So let's make that really large. I mean, for the visible vertex, it's 1 anyway, but yeah. Okay, 80. That seems right. That's not right. Am I getting max cost instead of min cost? Yeah, I have a test case. That's good. That's the hardest part, always finding a test case. Okay, so that what this should be is actually 60. And looks like I'm not making the back edges. Available? Oh, yeah, they need to have the same cost. Ugh. Or the reverse cost. No, sorry, the same cost. Let me just do this. Let me be correct about it. Okay. That's what I get for trying to code up network flow from scratch. Min cost max flow. Attempt number 3. It's interesting it actually worked for this case. Or wait, did it? 4840. Ugh. Maybe it didn't. Yeah, it didn't. Hooray! Okay. 387. 389. That was a pretty easy set, to be honest. I am slow and stupid, but it was a pretty easy set. Nothing really challenging. And this, I mean, I would have solved this in a lot less than 40 minutes if I had a pre-coded min cost max flow, which I do not. I really should rectify that. I am really impressed at how fast some of these people are. This was an easy contest, and these people just flew through it. I mean, I had to think a little on Matrygons, and I had to think a fair bit on hidden pancakes, and they did not do any thinking. This was purely a speed contest, nothing challenging. It took me 3 times as long as Radawoosh to get through everything. Ridiculous. Um, yeah, so I don't know what to say about this contest. I mean, so in theory, I could keep testing. Um, so I don't really expect this to actually affect anything. I guess the only mistake I could make here is if I didn't have int64 somewhere. Um, I mean, there are a couple of cases where I have ints, but they're fine. That's int64. Yeah. So since I'm using int64s for everything, this is not going to overflow. Um, I mean, the answer can't overflow, but the intermediate values, some of these intermediate costs actually could overflow if you were doing the wrong thing, I believe. So, um, possibly because you'd have, yeah, I think if you were moving like half of green tiles over to the other half of green tiles at maximum swapping cost, then I believe that would overflow. That'd be 50 times a million uh, times 10, 500 times a million. Actually, even that probably wouldn't overflow. They chose their limits to be pretty nice, actually. I'm not sure that you can overflow this problem. Um, but anyway, yeah, so given this test set 1 is not quite a full functionality test set, but there's nothing in my solution that actually relies on F and S being 1. Um, I guess, yeah, I could have a mistake where I didn't multiply this by S, for instance. So if my cost here was not multiplied by S, it would still look correct for test set 1. And if this was not multiplied by F, and this was not multiplied by F, then it would still look correct. But aside from leaving out the variable, I don't see how I could mess up F and S here. Um, it's interesting. I'm actually not that far off from not qualifying. Like, if I get if I get one of my problems wrong, it's possible I actually won't qualify. We'll see. Um, I have pretty high confidence in my hidden pancakes and retiling, but yeah, we'll see. Given that this was such a speed contest and I was not fast at all, I got quite a low rank, and round three is not assured. Yeah, I did actually have that question when I first saw the problem. But the thing is, you can't do better. It's fairly obvious that you cannot do better than the full range, and then the full range minus one, full range minus two, full range minus three, and so on. Like, you're getting the maximum amount of information from that. You need to use those ranges to get the smallest and the next smallest and the next smallest and so on. So that first problem was really not even a problem. That was just like, can you write an interactive problem in 3 minutes? And the answer for some of these people was yes. Can you solve an interactive problem in 3 minutes? For me, it took 10 minutes. I had to like work through the details of the interactive problem, but still, there was no thinking involved. This was so trivial. This, I had to think a little. It should have been obvious, but I had to think a little. This one, I had to think a lot. This one, I didn't have to think at all, but I also didn't have a min cost max flow coded up. So anyway, so that's my summary. I don't think I'm going to spend any more time checking problems. I think that's it for this video. So I'll just reiterate what I said at the beginning of this video. This Friday, I'll put this in the details as well. This Friday at 9 p.m. my time, I will go on Twitch. I mean, I will basically be doing a practice video, but I will be on Twitch so people can actually come by and ask questions if they want to, if you really want to. You don't have to, obviously, and I'm not even sure anybody will show up. But yeah, so I will basically be screencasting a practice of Google Code Jams round 1A and 1C, because I do need practice for round 3, obviously. And I will do it on Twitch on Friday and next Friday, and I'll maybe turn it into a regular thing. So also, if you have questions about the ICPC, since of course I am a judge for the ICPC World Finals, whenever that is going to happen again, if you have questions that aren't, what is the next problem set? But if you want to talk about problems I've written before, like, I've got a lot of problems I've written for the finals over the years, and I'm happy to talk about them. Happy to talk about other finals problems, or even ICPC in general. That's probably where my experience is a bit more valuable than talking about, say, code forces problems. Like, I don't know the current meta when it comes to a lot of these algorithms and a lot of code forces, a lot of the types of problems that show up on code forces and stuff like that. But I do have a fairly good idea of what shows up on the ICPC World Finals. So can talk about that. And yeah, so by the way, Neil Wu, who won round 1B, actually posted a screencast of winning round 1B. So it seems like these screencasts are getting more and more common. Like, these people at the top are screencasting, so that's great. That means I don't really have to do it. um, yeah, and obviously Ericto. Where is Ericto? Ericto wasn't quite as fast as. Am I missing him? I guess Ericto was not fast on this either. Ericto. Does he have a different? This isn't case sensitive, is it? Oh, there he is. Okay. Oh, Ericto also had to think about hidden pancakes. Maybe hidden pancakes was just a well-known problem um, for some of these people, or maybe it's a problem that they'd solved before. Because I did have to think about it slightly. I mean, I screwed up by not thinking about the largest pancake first, which should have been obvious. But Um, okay, so we did have to think a little on these two. So anyway, Ericto probably is screencasting as well. So you can watch Ericto's stream, and you can go to Ericto's Twitch stream, and EC Nirwala also has a Twitch stream. Is he there? Oh wow, he's right up in ninth. I didn't even see that. EC Nirwala is fast. That is the one thing that he is really good at. Well, I mean, one of the many things he's really good at. So yeah, he's so he also has a regular Twitch stream, which you might want to check out. I wonder if Tourist will ever start a Twitch stream. He has shown up in Twitch streams. I've seen him. I've seen him around, but as far as I know, he doesn't broadcast on Twitch. Anyway, that's enough chatter. So thank you. I will see you on Twitch, and I will see you for the shellacking that I'm going to be taking in round 3, because I am clearly not in round 3 form. Round 3 is probably where my Google CodeJam experience will end, or round 2 if I manage to get one of these problems wrong. But anyway, I will see you next time. Bye.